Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. William Herschel studied astronomy. In the year of 1781 he discovered me. I have an estimated age of 7 to 9 million years. As for an estimate, that's fine. I've exhausted my core of hydrogen fuel, becoming a supergiant after I expanded and I cooled. I expect to end my life as a type 2 supernova. Here is more, leaving a neutron star or black hole, but no one knows for sure. I'm classified as a blue-white supergiant star. How fun, which is a hot luminous star that's bigger than your sun. I belong to the Orion constellation. Locate me from the celestial equator, from Earth on my run. I am visible throughout the world, of this I am sure. Located in the hunter's leg of Orion, I assure. From the Earth my distance is 860 light years to be clear. 1 light year is the distance light travels in 1 Earth year. 61,500 to 363,000 times as luminous as the sun. My brightness is so grand, but I'll vary slightly in brightness until the day I'm done. I'm thought to be 18 to 24 times more massive than your sun. My radius is a straight line from my center to my circumference, which is more than 70 times that of your sun in reference. My surface temperature is 12,100 kK, meaning Kelvin, a base unit of temperature in the SI. I say, the next time you're out at night, look for Orion in the sky. Look for the hunter's leg. I'm bright to the naked eye. My name is Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. My name is Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. WASP-103's an F-type main sequence star. You see, it's located far away in the constellation Hercules. WASP-103's an F-type main sequence star, that's me. I have an elongated planet named WASP-103b. My name's WASP-103, an F-type main sequence star. You see, located far away in the constellation Hercules. Hercules is 2,100 million light years away from the Earth, in the solar system is where I stay. I have a concentration of heavy elements similar to your sun, but I'm slightly younger than the star of your solar system. I'm too hot for star spots to form within, so I have solar facula. It means little torch in Latin. WASP-103's an F-type main sequence star. You see, it's located far away in the constellation Hercules. WASP-103's an F-type main sequence star, that's me. I have an elongated planet named WASP-103b. I do have a planet found in 2014. I will introduce this planet called WASP-103b. My name is WASP-103b. I'm not sure I'm a dwarf candidate, but I'm classified as a super Jupiter planet. I'm much more massive than Jupiter, your planet so large. I'm 1.5 Jupiter masses spinning through space as I charge. I'm located 1,225 light years from Earth in the Hercules constellation. I set forth. My shape isn't round to any degree. I'm elongated like a potato or a rugby ball you'd see. My atmosphere contains water and possibly hydrogen cyanide and titanium oxide around me. I may be a carbon planet. You wonder what is that then? It's a theoretical planet containing more carbon than oxygen. I orbit my main sequence star WASP-103 once every 22 hours. I hope you'd agree. WASP-103's an F-type main sequence star. You see, it's located far away in the constellation Hercules. WASP-103's an F-type main sequence star, that's me. I have an elongated planet named WASP-103b. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I was first catalogued in 1860 by German astronomers at Bonn Observatory. I was named BD-125055 until my second survey I was found to be slightly more bright. That's when I was named UI Scuti, the 38th variable star of the constellation Scutum am I. I'm the largest known star in the Milky Way galaxy, but because I'm so far from Earth, you need a telescope to see me. I'm 30 times the sun's mass, but I have a radius more than 1,700 times greater than the Earth's sun I span. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I'm 9,500 light years away from your Earth. 1 light year equals about 5.88 trillion miles for what that's worth. I'm known to be one of the most luminous stars, and I am a red supergiant. I hope you like me so far. I'm close to the supermassive black hole Sagittarius A, Galactic center, which is the center of our galaxy. I'm so large, if you replaced your sun with me, my photosphere would span past Jupiter's orbit. As you can see, I've begun to fuse helium and continue to fuse hydrogen in the shell around my core based on models of stellar evolution. After fusing heavy elements, my core will begin to produce iron, disrupting the balance of gravity and radiation in its core and resulting in a core collapse supernova, which is expected in stars like me. Look for me in the night sky within your galaxy. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I'm a quasi-star, also called a black hole star. How bizarre, I'm a hypothetical type of extremely massive luminous star. I'm a quasi-star, I may have existed early in the history of the universe. Now let's learn more about me. I'm a quasi-star, and I am hypothetical, but what's this? It means I haven't been proven as yet to exist. I'm a theorized star, bigger than a red supergiant star. At 10 billion kilometers in radius, I'd be the biggest by far. Here's a size comparison of what I'd look like hypothetically in our universe against other stars, so you can clearly see. Let's start with your sun in the center of your solar system with a radius of 696,347. The sun is classified as a yellow dwarf star, which is massive to humans but very small compared to other stars. I'm 7,000 times the size of your sun, which is quite impressive in size. I'd be bigger than anyone. This is Pollux, a red giant star. It's 5.5 million kilometers in size this far, but when you compare it to me, it really looks tiny. I would consume it if it got too close, pulling it in with my gravity. Here's a red supergiant star going by the name of Betelgeuse with a radius of 617 million kilometers of energy to produce. But when compared to me, it is plain and clear to see I am tremendous next to it. Let's move on to the next star next to me. This is UI Scuti, a red supergiant as well. At 1.1 billion kilometers, it's massive, you can tell. This is what it looks like when compared to me in size. It's hard to fathom just how massive I am, it's no surprise. This is a red supergiant, or possibly a red hypergiant star. It goes by the name of Stephenson 2-18. It's a biggest by far. It has a radius in kilometers of 1.4 billion in size. As you can see, it's small compared to me in the night sky. Maybe astronomers can discover a quasi-star like me someday. You could study astronomy and make me a reality. I am the Canis Majoris, one of the largest stars known in the present universe. I am the Canis Majoris. My home's a Milky Way galaxy, this is an interstellar course. I'm believed to be discovered in 1801, when French astronomer Jerome Lalande logged me in my recordings begun. A red class M hypergiant's what I'm classified as. Now let's focus a bit closer on what makes up this star class. Hypergiant stars show tremendous luminosities and have very high rates of mass loss by stellar winds, you see. My distance from the Earth is about 4,000 light years away. 1 light year equals about 5.9 trillion miles, I'd say. I used to be the largest star in the universe, you see, until some hypergiants like Scuti dwarfed me. I am the Canis Majoris, one of the largest stars known in the present universe. I am the Canis Majoris. My home's a Milky Way galaxy, this is an interstellar course. If you wanna locate me while looking up in the night sky, you'd have to use the telescope. You can't see me with the naked eye. If you have a telescope pointed to the constellation of Canis Major and look to the left to the Delta Star for a fixation. 990 million kilometers is my radius. Aren't you glad you are paying attention and learning all of this? 5,822 degrees in Fahrenheit is what my temperature is thought to be. I'm hot and extremely bright. And if I replace the sun in your present solar system, I would consume all planets past Jupiter like they were crumbs. I am the Canis Majoris, one of the largest stars known in the present universe. I am the Canis Majoris. My home's a Milky Way galaxy, this is an interstellar course. Massive stars like me, we live a very, very short life. I'm reaching the end of my existence, which is part of my strife. I rapidly shed mass because I'm running out of fuel in my course. Scientists think I'll explode into a supernova, but no one knows for sure. I am the Canis Majoris, one of the largest stars known in the present universe. I am the Canis Majoris. My home's a Milky Way galaxy, this is an interstellar course. I am the Canis Majoris, one of the largest stars known in the present universe. I am the Canis Majoris. My home's a Milky Way galaxy, this is an interstellar course. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I'm a molecular cloud, I'm a type of nebula. I have a high density and a very low temperature. This combination creates a gas, molecular hydrogen. That's primarily what I'm made of, along with cosmic dust within. When the force of gravity exceeds the outward push of gas, the pressure is so great that I can't help it and start to collapse, which is caused from a shockwave from a near exploding star, or when two molecular clouds collide. Now isn't that bizarre? When the gravity's too strong, I break apart into smaller clouds. Each cloud is a star's beginning, in which I am very proud. Protostars are the name of the clouds that do break free. Let me introduce a protostar that was a part of me. Hello there, I'm the beginning of any kind of star. Let me introduce myself to you. I am a protostar. protostar. My core is not hot enough for fusion to occur. To achieve that level of stardom, that process is a chore. The first thing I do when I break free from my molecular cloud, I start to spin until I form this disk around me you see now. As the disk rotates, I produce a strong magnetic field, pulling gas and dust into my center core as I reveal. The infalling gas releases a kinetic energy, creating heat, increasing the temperature in the center of me. At this point I can transform into a hydrogen burning star, which is when the nuclear fusion starts in a protostar. This is when I cross over to stage 3 called Centauri. We play our different roles in the star formation you see. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I'm a T-Tauri star now, also a pre-main sequence star. My job's to clear away the dust and gas and send it really far. My stellar winds create bipolar outflows that decrease my mass till I'm a main sequence star, my center burning nuclear gas. Now I'm a main sequence star now, just like the sun, you know. For billions of years I will burn throughout my light show. Converting hydrogen to helium is how fusion exists. It wants to blow me apart but has a hard time doing this. Cause of gravity of equal power pushing me in, I'm able to stay burning since the fusion did begin. There are many different kinds of stars throughout the universe. Go learn about them all now that you know how they are birthed. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I'm a star surrounded by a circumstellar disk. My name is HG100546. I'm a star surrounded by a circumstellar disk from the constellation of Musca. Now hear this. My name is HG100546. I'm 316.4 light years from your Earth with exoplanet. I'm a star with a circumstellar disk from the distance of 0.2 AU to a few hundred AU. Now this, I'm found in the constellation of Musca. Hear this. I'm a B-type star with an exoplanet that does orbit. I have an exoplanet that goes by the name you see. It is HD100546b. I'm HD100546b. I was discovered at the Very Large Telescope in Chile. Astronomers think I might be a large planet or brown dwarf located in the disk around my star on my orbital course. I'm a gas giant exoplanet, they know this for sure. My mass is 752 Jupiters. One orbit takes 249 years around my star. I'm 53 AU away from my star, that is far. My discovery was announced in 2014. That's all I have to report, that's enough about me. I am back again, it's HG100546. Let me tell you a bit more about my disk. My circumstellar disk was observed by the Hubble telescope, which showed spiral patterns. What they mean, no one really knows. My disk is fairly flat with a circular shape, with a wide gap thought to be carved by my exoplanet. How great! When looking at the night sky, try to locate the constellation of Musca, but you have to look late. I'm a star surrounded by a circumstellar disk. My name is HG100546. I'm a star surrounded by a circumstellar disk from the constellation of Musca. Now hear this. all stars, we're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. I'm the crab pulsar, a young neutron star. I'm Calvera, an isolated neutron star that's far. My name's Vela X1, I'm a neutron star as well. Sirius B, that's me, a small white dwarf as you can tell. I'm EBLMJ0555-57AB. My name's TRAPPIST-1, an ultra cool red dwarf star in sight. I'm Proxima Centauri, a main sequence red dwarf star. I am your sun, a yellow dwarf that isn't too far. Alpha Centauri A is an orange star, you see. I am Sirius A main sequence star, that's me. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. VFTS 352, contact binary 1 and 2, composed of two very hot, bright, massive stars that orbit each other, it's true. My name is Pollux, a red giant star here. Arcturus is a red giant star, I hope I made that clear. R136A1 is a wolf riot star thus far. I'm Aldebaran, a red giant star, that's me. Rigel is here, a blue-white supergiant you can see. I am Betelgeuse and I'm a red supergiant in class. VY Canis Majoris, a red hypergiant star with mass. I'm UI Scuti, the biggest red supergiant this far. Join us to sing the chorus, now get your head out of the stars. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. We're Alpha Centauri, the closest star system to the solar system your Earth is from. Alpha Centauri is a triple star system. We're 4.37 light years away from your sun. We're Alpha Centauri A and Alpha Centauri B, which forms a pair of stars called binary. Alpha Centauri A officially Rigel Centaurus. Alpha Centauri B officially Toleman I trust. Centauri C officially Proxima Centauri. Here we'll learn about our size and our luminosity. Alpha Centauri A and B are sun-like stars. We're the brightest stars in the constellation Centaurus by far. Alpha Centauri A has 1.1 times the mass and 1.5 times the luminosity of the sun in this class. Alpha Centauri B is smaller and cooler, you should know, at 0.9 times the sun's mass and 0.4 the luminosity shown. We orbit around a common center or around one another, so you'd understand better, with an orbital period of almost 80 years by far. And from a distance we're so close we look like one star. I'm Proxima Centauri, a small and faint red dwarf star. You cannot see me with the naked eye, though I'm the closest star by far. I'm about 4 4.24 light years from the Earth, and I'm the closest star to the sun for what that is worth. Discovered in 1915 by astronomer Robert Innes, I'm sure, in South Africa at the Union Observatory in Johannesburg. My Latin name Proxima Centauri means when this is defined, the nearest star of Centaurus, that's all that's assigned. We're Alpha Centauri, the closest star system to the solar system your Earth is from. Alpha Centauri is a triple star system. We're 4.37 light years away from your sun. We're Alpha Centauri A and Alpha Centauri B, which forms a pair of stars called binary. Alpha Centauri A officially Rigel Centaurus. Alpha Centauri B officially Toliman I trust. Centauri C officially Proxima Centauri. Here we'll learn about our size and our luminosity. I am the sun, the center of your solar system. I do erupt intense high energy radiation. This radiation I expel is called the solar flare. You'll learn about them in this song and why you should care. The sun is a ball of plasma, like an extremely hot ocean shaped like a wheel. This plasma is pushed around and shaped by the sun's magnetic field. When the sun's plasma swirls around by its magnetic field, it gets twisted and releases energy around sunspots, they are real. This energy released is caused by magnetic knots. When one of these knots breaks, it releases solar flares, so you are taught. Solar flares are waves of high energy radiation shot through the solar system in which we are all one. These solar flares race through space at the speed of light, creating a solar proton storm. These storms are no delight. When millions of tons of plasma are thrown from the sun's atmosphere, these storms are called coronal mass ejections, as you see right here. These CMEs reach speeds of 5.6 million miles per hour. When they hit Earth, it doesn't hurt living beings, even with such power. The Earth's atmosphere protects life from the biggest solar storms by absorbing the impact, so beings on the surface are safe from harm. When a CME is too big, it creates a solar superstorm that occur once or twice a century, so you've been warned. If a solar superstorm did happen in this day and age, it would shoot billions of tons of plasma from the sun, I do say. If this type of CME traveled across space towards the Earth, it would reach you in one day. Yeah, that's fast for what that is worth. Its shockwave would compress Earth's magnetic field, making it frail. The two magnetic fields would merge, stretching Earth's field into a thin tail. This stretched tail can't contain this energy anymore. When it snaps, it releases explosive energy towards the Earth that it stored. This creates something very rare called the geomagnetic storm. Normally no living thing on Earth would even know it had formed. The only thing it would affect is your electricity, because you rely on this so much it would disrupt human life, you see. Because Earth is covered in millions of electric wires and transformers, this geomagnetic storm would shut down the power, humans would be overturned. If one of these storms hit the Earth, electricity and internet would not work. All things powered by electricity would turn off along with all networks. Computers wouldn't work along with phones and electronic devices. No refrigerators or any other household appliances. Even though we can't stop these terrible solar storms, their nasty side effects can be prevented by how we are warned. Engineers would have a day or two to unplug major power grids until the solar storm passes Earth, preventing blackouts we forbid. Humans need to prepare for these types of storms to prevent being thrown back to the Stone Age before they form. A cool event humans experience from any solar storm is the aurora borealis. At the two poles is where they perform. I'm the life-giving sun, you all need me to live, but I am unpredictable, so solar storms I give. I am the sun, the center of your solar system. I do erupt intense high energy radiation. This radiation I expel is called the solar flare. You'll learn about them in this song and why you should care. I am Betelgeuse, I'm nearing the end of my life. One of the top 10 brightest stars up in the night sky. I am a red supergiant expected to explode into a supernova in 100,000 years or so. I received the name Betelgeuse in 1836 by Sir John Herschel, an astronomer and a great scientist. I'm the second brightest star in the Orion constellation. After the star Rigel, we're seen from any of Earth's nations. My diameter's about 700 times that of your sun, and I'm 640 light years from the Earth. That's quite a run. But my surface temperature 6,000 degrees in Fahrenheit, cooler than your sun's surface 10,000 degrees. Yeah, that's right. I'm so massive, if you replaced your sun with me, I'd reach past the orbit of Jupiter. I'm gigantic, you see. I'm considered a young star at just 10 million years old, soon to explode into a supernova. Scientists say so. I am Betelgeuse, I'm nearing the end of my life. One of the top 10 brightest stars up in the night sky. I am a red supergiant expected to explode into a supernova in 100,000 years or so. A red supergiant is an aging giant star that has consumed its core supply of hydrogen fuel. That's what they are. Helium has accumulated in my core so well, and hydrogen's undergoing nuclear fusion in my outer shells. When my outer shells expand, I take on a red color. Because I'm cooler than I was, I'm happy to discover red supergiants are the largest known stars in the universe, and I'm expected to supernova onto the next verse. During fusion, heavier atoms are created until my core is iron. That's when I'll run out of fuel without even trying. When that happens to a star as massive as me, the entire star collapses and explodes as a supernova. You see, when I do supernova, I'll create quite a sight. Some predict I'll even look like your full moon's brightest light. The radiation I put off from becoming a supernova wouldn't affect Earth because I'm 640 light years over. I am Betelgeuse, I'm nearing the end of my life. One of the top 10 brightest stars up in the night sky. I am a red supergiant expected to explode into a supernova in 100,000 years or so. I'm Stephenson 2-18, red supergiant star, the biggest you've ever seen. The new biggest star in the universe am I am much larger than you, Scuti. My name is Stephenson 2-18 is seen, also known as RSG C2-18. I'm the new largest star found by man, you know, replacing you, Scuti, and other largest stars shown. I'm a red supergiant, the largest stars in the universe. In terms of volume, you just learned this in this verse. If Stephenson 2-18 replaced the sun in the solar system, its photosphere would extend beyond the orbit of Saturn. I have an estimated radius of 2,150 times that of the sun. Here's a bit more about me. My volume's about 10 billion times greater than the sun. A little fact you should know. Don't go, I'm not done. I was discovered by an American astronomer, Charles Bruce Stephenson, in 1990, I'm sure. I'm a red supergiant in the constellation of Scutum. Let's see how far I am from your nation. I'm roughly 20,000 light years away from Earth, you see. I shine with 440,000 solar luminosities. I have an estimate of 2,150 solar radii. That's bigger than the star of you, Scuti. My effective temperature is thought to be 3,200 K. K meaning Kelvin. I have so much more to say. I'm the new champion of the universe, largest stars by size. Try to find me with your eyes when looking to the night sky. I'm Stephenson 2 Jupiter and Saturn will come within 0.1 degrees of each other, forming the first visible double planet in 800 years. Will clutter on the winter solstice, December 21st in 2020. Look to the night sky to see this event, the joy it'll bring is plenty. Alignments between Jupiter and Saturn are pretty rare, only occurring around once in every 20 years. But this upcoming conjunction's exceptionally rare, only because of how close we planets will appear. It's said the last time this occurred was in medieval times. In the year of 1226 was the closest that we aligned. Alignments between these two planets happens once every 20 years. But this conjunction will be very rare because of how close we appear. We'll be aligning on the same day as the winter solstice. On December 21st, 2020, the whole world can witness this. If you live in the northern hemisphere, looking low in the southwestern sky, you can see it shining bright shortly after sunset with the naked eye. We'll appear extremely close for about a month ahead, but we won't make such a close approach again until the year 2400. Typically Jupiter orbits the sun every 12 years. Saturn's orbit around the sun takes about 30 years. Every couple of decades, Jupiter laps Saturn in flight. Be sure to watch the sky December 21st in 2020 at night. Jupiter and Saturn will come within 0.1 degrees of each other, forming the first visible double planet in 800 years. Will clutter on the winter solstice, December 21st in 2020. Look to the night sky to see this event, the joy it'll bring is plenty. Jupiter and Saturn will come within 0.1 degrees of each other, forming the first visible double planet in 800 years. Will clutter on the winter solstice, December 21st in 2020. Look to the night sky to see this event, the joy it'll bring is plenty. I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. All of the planets in our solar system, they orbit while they follow me. 230 million years is the time I take to fly around the Milky Way galaxy. I don't have a solid surface, I'm made up of gases held together by my own gravity. I'm made of 92.1% hydrogen H2 and 7.8% helium He. I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. My core is 25% of my total mass and 27 million degrees. My energy is the reason there is life on Earth. There'll be no charge 'cause I'm totally free. My mass makes up 99.8% of our solar system. Nothing in our system's hot as me. I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. Let's fly, let's fly, let's fly, let's fly, let's fly, let's fly, let's fly. am 2021 PH 27. I am currently the new closest object to the sun. I stole Mercury status of the sun's closest object. I'm here to prove this to you after my facts are checked. Discovered by Scott Shepard at the CTIO on August 13th, 2021 in the country of Chile, you know. Scott Shepard discovered me using the Dark Energy Survey, or DES for short. In space I'm on display. I was discovered at apparent magnitude 19 from the Earth. Let me explain just what that means. Apparent magnitude is a measure of the brightest of a star or other astronomical object observed from Earth so far. I am 2021 PH 27. I am currently the new closest object to the sun. I stole Mercury status of the sun's closest object. I'm here to prove this to you after my facts are checked. My perihelion is closer than Mercury at the closest orbit to the sun. My aphelion is farther than Venus when my orbit is farthest from the sun. I have the smallest semi-minor axis. Have fun. And shortest orbital period among all asteroids as of 2021. I take 113 days to orbit the sun. That makes me the fastest orbiting asteroid, and I'm not done. I'm expected to be larger than 1 kilometer in diameter. Next to Mercury's diameter of 4,800 kilometers, I'm smaller. Professionally designated 2021 PH 27 while orbiting the sun by the minor planet center on my run. None of this info would be possible without astronomers. Maybe you could study astronomy, it's out of this world, I'm sure. I am 2021 PH 27. I am currently the new closest object to the sun. I stole Mercury status of the sun's closest object. I'm here to prove this to you after my facts are checked. I am 2021 PH 27. I am currently the new closest object to the sun. I stole Mercury status of the sun's closest object. I'm here to prove this to you after my facts are checked. One of the biggest storms in our solar system is the Great Red Spot on the 5th planet from the sun. Jupiter's high pressure region is persistent and long, with wind speeds that would dwarf Earth's storms that are strong. In the atmosphere on the 5th planet from the sun, on the planet Jupiter is where the storm begun. In the 17th century, astronomers turned their telescopes to planet Jupiter with nothing but hope. They said they saw a spot in the planet's atmosphere, but it could have been in a different belt they saw in their years. Astronomer C.W. Pritchett rediscovered on a date the Great Red Spot in 1878. He looked closely in the southern hemisphere, a spot spinning counterclockwise, and it was made clear the high pressure system was definitely a storm that lasted over 350 years since it was formed. The Great Red Spot, it was officially named since astronomers' telescopes did take aim. It produces wind speeds of 250 miles per hour, but from a distance looks like red beauty with power. Jupiter's dry atmosphere is made up of elements I name: hydrogen, helium, ammonia, and methane. These same elements are what made up the sun. So why didn't Jupiter become a star on its run? Jupiter's not massive enough, so it's called a failed star. There's not enough internal pressure to create the fusion. It's bizarre. 10,159 miles wide. It's so massive you could fit 2 Earths inside. The Great Red Spot is like a hurricane on the Earth, but much more powerful and larger since its birth. One of the biggest storms in our solar system is the Great Red Spot on the 5th planet from the sun. Jupiter's high pressure region is persistent and long, with wind speeds that would dwarf Earth's storms that are strong. A galactic tides, a tidal force so real, experience objects by a gravitational field of a galaxy such as the Milky Way. But these types of tides only happen in space. There are particular areas concerning galactic tides, like galactic collisions when two galaxies collide, the disruption of a dwarf or a star-like galaxy, which creates a new elliptical supergalaxy. These tidal effects are usually limited to the immediate surroundings of a galaxy, it is true. In theory, in about 5 billion years, astronomers have theorized our galaxy's biggest fears. Astronomers think the Milky Way will be pulled by gravity towards Andromeda, the nearest galaxy. A galactic tide will pull these two galaxies in a close encounter to each other through gravity. When this happens, the center of the galaxies will certainly merge, pouring gas towards the center, igniting an explosion for sure. This will create star formation 100 times faster than a galaxy does today, says the astronomers. For example, take our tides in the ocean, attracted to the gravitational pull from the moon's motion. When the moon is on one side of the earth, the ocean is higher on that side, pulled by the moon's gravitational force. The galactic tide is similar, you can see. It all has to do with this thing called gravity. A galactic tide's a tidal force so real, experienced by objects by a gravitational field of a galaxy such as the Milky Way. But these types of tides only happen in space. How is Earth habitable? Why can life thrive on it? While the sun's plasma blasts towards us, what's protecting it? We're protected by Earth's magnetosphere, also called Earth's magnetic field. Let's learn more right here. There's a region around the planet beyond the atmosphere, created by Earth's internal magnetism called the magnetosphere. The reason life developed and continues to keep us alive is because of this magnetic environment, it's why we thrive. What's this magnetosphere and what does it protect us from? Let's take a closer look as we move towards the sun. When the sun blasts plasma from the solar storm, it emits huge bursts of energy and solar flares form. Solar flares are bursts from the sun during an eruption, pushed into space as solar and cosmic particle radiation. This electromagnetic radiation from the sun does reach the earth and could destroy the atmosphere while on its run. But the atmosphere's protected when these particles reach it by the magnetosphere, deflecting when these particles do hit. The magnetosphere changes shape when blasted with these particles, directing them away from the atmosphere so they aren't harmful. If our atmosphere were to deteriorate over time, life on Earth would perish. You've learned this in this rhyme. Some of the particles aren't deflected away, but have no fear when they get trapped in Earth's magnetosphere. The trapped particles get shot towards Earth's two poles in the field lines, also called the dipole, which means two poles. When these particles reach the atmosphere, they react with oxygen and nitrogen, causing the auroras that appear. Let's take a closer look at where this magnetosphere is formed. We'll slice the Earth in half so you're visually informed. The electrically charged molten iron churns for sure below the Earth's surface within the planet's outer core. This generates a magnetic field large enough to race far past our Earth's atmosphere out into space. I'm a supermassive black hole found in the center of almost all massive galaxies. I'm a supermassive black hole. There are theories of how I'm formed. Come and join me and see. There are three types of black holes according to theory: primordial, stellar, and supermassive like me. The primordial's a tiny hypothetical black hole. In 1974, Stephen Hawking theorized its role. Primordials were formed in the early universe, but we'll learn about this more when I teach that topic's course. On to the most common type called the stellar black hole. But let's first see why a star exists before it loses control. The pressure from the nuclear fuel in the core pushes outward so greatly, while the force of an equal power pushing in is caused by gravity. This equal pressure does create the star's main sequence stage. That means the star is stable in its present burning age. When stars with the sun's mass run out of nuclear fuel in its core, it becomes a red giant that quietly becomes a white dwarf. But stars with 25 the mass of your solar system sun runs out of nuclear fuel, its gravity crushes the core and becomes a stellar. It's the most common type in the universe. Now I will tell you how I'm created, of course. I'm a supermassive black hole, the third type of black hole seen, believed to be found in the center of any major galaxy. A black hole's a region of space where the force of gravity is so strong that nothing, not even light, can escape. You've learned in this song. How I acquired my mass is still yet to be determined, and astronomers are still working on how I'm formed, that is certain. Some think I'm formed from the collapse of a massive cloud of gas during the early stages of the formation of galaxies with mass. My parts start with the accretion disk orbiting around me. It's superheated gas and dust swirling around the singularity. The singularity is the very center of a black hole you see, made up of matter collapsed into a region of infinite density. The event horizon's the radius around the singularity, which energy and matter cannot escape the black hole's gravity. The innermost stable orbit's the last place material orbits safely without the risk of falling past the point of no return in me. A photon sphere's a location where gravity is so strong that light can travel in circles, and orbiting the black hole are photons. 9 feet on stars, dust and gas, and produce jets of near light speed, blasting particles and radiation out of my poles, as you can see. These are relativistic jets, and the last part I'll talk about. Thank you for learning with me. Now I am out. Is that a shooting star through the night sky, or could that be a space debris flying by? There is so much space debris created by humans every year that eventually come back down through Earth's atmosphere. There are 160 million objects orbiting the Earth, creating real concern for space flight to move forth. The space debris can move at dizzying speeds of over 15,000 miles per hour. These are speeds that you can't see. Is there reason for concern? Does it affect humankind? It certainly does. Let's take a closer look to see what we find. If an astronaut's on the space station on a spacewalk to fix something at the space station to try and beat the clock, then a piece of space debris is orbiting through space. It could hit the astronaut, tearing a hole in his suit. Now brace. If you love the internet and rely on satellites, and a satellite is orbiting the Earth on its daily flight, a tiny piece of space debris traveling at dizzying speeds of 15,000 miles per hour on its path it proceeds. When it hits a satellite, it could damage it permanently, knocking out the internet with any size of the space debris. What is space junk and how does it come to be? Let's look at some examples as they fly by. We will see. This discarded launch vehicle is space junk. Also, this old discarded astronaut glove can create a funk. A dead space satellite is the trash I'm speaking of. Even tiny pieces of metal shot from mankind above. When the space debris continues to collide, creating more, we could create a Kessler effect, so space we can't explore. A Kessler effect is when space debris continues to collide, creating an endless debris field. No satellites survive, no spacecraft could leave the Earth to explore the universe. If we don't clear this junk, we'll be stuck on the surface of Earth. Is that a shooting star through the night sky, or could that be a space debris flying by? There is so much space debris created by humans every year that eventually come back down through Earth's atmosphere.
My name is Rigel.
a blue-white supergiant star in the Orion constellation. I am the brightest so far. William Herschel studied astronomy. In the year of 1781 he discovered me. I have an estimated age of 7 to 9 million years. As for an estimate, that's fine. I've exhausted my core of hydrogen fuel, becoming a supergiant after I expanded and I cooled. I expect to end my life as a type 2 supernova. Here is more, leaving a neutron star or black hole, but no one knows for sure. I'm classified as a blue-white supergiant star, how fun, which is a hot luminous star that's bigger than your sun. I belong to the Orion constellation. Locate me from the celestial equator, from Earth on my run. I am visible throughout the world, of this I am sure. Located in the hunter's leg of Orion, I assure. From the Earth my distance is 860 light years to be clear. 1 light year is the distance light travels in 1 Earth year. 61,500 to 363,000 times as luminous as the sun. My brightness is so grand, but I'll vary slightly in brightness until the day I'm done. I'm thought to be 18 to 24 times more massive than your sun. My radius is a straight line from my center to my circumference, which is more than 70 times that of your sun in reference. My surface temperature is 12,100 kK, meaning Kelvin, a base unit of temperature in the SI, I say. The next time you're out at night, look for Orion in the sky. Look for the hunter's leg. I'm bright to the naked eye. My name is Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. My name is Rigel, a blue-white supergiant star in the Orion constellation. I am the brightest so far. WASP 103's an F-type main sequence star. You see, it's located far away in the constellation Hercules. WASP 103's an F-type main sequence star, that's me. I have an elongated planet named WASP 103b. My name's WASP 103, an F-type main sequence star. You see, located far away in the constellation Hercules. Hercules is 2,100 million light years away from the Earth in the solar system is where I stay. I have a concentration of heavy elements similar to your sun, but I'm slightly younger than the star of your solar system. I'm too hot for star spots to form within, so I have solar facula. It means little torch in Latin. WASP 103's an F-type main sequence star. You see, it's located far away in the constellation Hercules. WASP 103's an F-type main sequence star, that's me. I have an elongated planet named WASP 103b. I do have a planet found in 2014. I will introduce this planet called WASP 103b. My name is WASP 103b. I'm not sure I'm a dwarf candidate, but I'm classified as a super Jupiter planet. I'm much more massive than Jupiter, your planet's so large. I'm 1.5 Jupiter masses, spinning through space as I charge. I'm located 1,225 light years from Earth in the Hercules constellation. I set forth, my shape isn't round to any degree. I'm elongated like a potato or a rugby ball you'd see. My atmosphere contains water and possibly hydrogen cyanide and titanium oxide around me. I may be a carbon planet, you wonder what is that then? It's a theoretical planet containing more carbon than oxygen. I orbit my main sequence star WASP 103 once every 22 hours, I hope you'd agree. WASP 103's an F-type main sequence star. You see, it's located far away in the constellation Hercules. WASP 103's an F-type main sequence star, that's me. I have an elongated planet named WASP 103b.